you guys for joining in today's session. Despite it being a weekend, I know you all have your own busy schedules and you have taken out the time to join today's session. So thank you for that. It's great to see you all this morning. For those of you who are completely new to C++, let me be frank. I feel like it's highly impossible to learn any programming language by simply seeing a tutorial or someone, even if someone's teaching it to you for that matter. Yes, you can definitely learn the concepts. You can learn why the programs work and all of that, but to be a pro at it, to be good at it, to know how everything works, to be a good coder, you need to get your hands dirty. And so I insist you guys, practice every day. Like even if it's not every day, say the weekends, whenever you're free, make it like a ritual. Just sit down and whichever IDE you're comfortable with that supports the particular programming language you want to learn. Say, for example, for C++, you have your Visual Studio and you also have code blocks, Dev C++. There's so many. Just get comfortable with that. See how the platform works for you, how it debugs, how it compiles, how it gives the errors, etc. And code, make it a ritual. Like say, you sit down from this time to this time, sit down and practice it, learn it, code it. And also go the authentic way, I would say. Just, take a pen, take a paper, maintain notes. Like whatever you learn for that 1 hour, just write down those keywords, those concepts, those, those particular terms. Just write them down, make notes. And so that the only motive is that so that at the end of the day, it gets easier only for you. And once you've made up your mind, of course, there's no stopping to you. For those of you who are already familiar with C++ and you're here today, kudos to you guys. I really appreciate you guys for coming here. I'll be touching upon some of the basic concepts today, like, the for loop, the conditional statements, and just here and there, like the header files, the print statements, for example, cout, cin, and the kind of header files you need, what are the keywords that we have, the different data types, these basic concepts. And I'm hoping that this will be a good revision for you guys. Having said that, let's move on to today's agenda. Also, quickly, if you guys can see my screen and you can see the PPT, can I quickly get a thumbs up in the comment section or this chat box, whatever you would like to call it? If you guys can see the screen, can I quickly, please get a thumbs up or a yes in the comment section so I know you guys can see my screen? All right. So the agenda for today, in this session, basically, I'll be telling you guys what exactly C++ programming is. I'll also be telling you, what was the need, or what were the other languages. It's not that there weren't other languages before C++, right? There was C and so many other languages. Who was the developer of C++, and what was his basic intention? Like, what did he think was missing in the other programming languages that he found the necessity to make another language and implement those concepts? What were those concepts? And I'll go on to some of the features again, and then we'll go on to a little bit of the coding part of it. I'll be taking you to code blocks. And I'll just show you some basic programs. I just want you guys to get the concepts. And of course, after that, we'll go on to a little bit of pros and cons and applications of C++. And towards the end, we'll go on to the summary, and I would love to take up any queries or questions that you guys have. And all right, having said that, let's move on. What is C++? Okay. As you can see on your screens, C++ is a high-level language, and it's object-oriented, which means object-oriented is basically, there are a lot of concepts in object-oriented. I won't get to that, but for example, there's data encapsulation, there's polymorphism, there's classes, and all of that. So C++ is an object-oriented programming language. It supports these features. It's a general-purpose programming language. Now, what do you mean by a general-purpose programming language? Basically, C++ is used to develop different OS operating systems, browsers, games, and so on. So there's that flexibility which you have with C++. And not only does C++ support the latest features that represent real-world problems, but it also implements the low-level manipulation problems. What do you mean by low-level manipulation problems? It's nothing but C++ also gives you this feature of pointers. And pointers, I won't get to the concept of it just at this stage, but pointers is something which you can manipulate. You can make manipulations in the memory part of the program where your variables are stored. You can store their address, the variable's address, etc. All those manipulations can be done using pointers. Now, so because as programmers, we can manipulate the memory part of it. That's why it says implementation of low-level manipulation problems. And for those of you who might be already familiar with C or Java or both of it, you would realize that these two languages are closely associated with C++. Let's move on to the next slide. All right. History of C++. Also, okay, before I can just continue, can I hope the space is fine for you guys. It's neither too fast nor too slow for you guys. If the space is okay, you guys, I would love to see a thumbs up again in the comment section. All right, thank you. So, as you can see, the developer of C++, Bjorn Stroustrup, he found that the initially C programming language lacked certain simulations, and thus he decided to develop a language that would overcome the drawbacks that were offered by the C programming languages. And so he developed C++ in the early 1979, and by adding some of his own features from his favorite programming language, Similar. Similar was a programming language which was then used a lot, but it's not much of use. I mean, people don't use it often these days. And right, so the basic motivation, the motivation for developing C++ was driven by the fact that he faced certain problems while analyzing the Unix kernel. So Unix kernel it's nothing but an operating system which was first developed in the early 1960s. Okay, and so, yes?
Ma'am, can you record it now?
I think the session is already being recorded.
It is being recorded by a third-party software.
All right. So it's being recorded, guys. You don't have to worry. Okay. So yeah, having said that, so C++, they developed it in this particular lab called AT&T Bell Labs, and the term was first coined by Rick Massetti. Then coming on to the ANSI. The ANSI, it stands for American National Standard Institute. So basically, it's a fancy term, but it's just a C++ community which was formed that led to the maturation of C++ to tackle the real-world problems by the implementation of object-oriented programming. It's basically a fancy term. This committee was just set up so that they can monitor how C++ works for the end users, and they can modify and all of that, the kind of header files we want to use, and we'll get to that in the next slide. All right, as you can see, the ANSI/ISO. ISO stands for the International Organization for Standardization, almost like another committee for that, a C++ committee that kind of set the rules and how basically they wanted C++ to work for the users, for the programmers. And back then, we used hash include. This is like a header file. I'll explain this in detail, what exactly hash include is. And when we go to code blocks, I'll explain it there in detail. Don't worry about that. So hash include and IOStream. IOStream is a header file. Why do we need, this is the basic header file you will need in your programming language in C++, because the least we want a programming language to do for us is generate an output, right? Be it a calculation, be it just a hello world, a string that you want to print, whatever. You want your program to print something, right, onto your monitor, and this helps us use those functions, cout and cin. I'll get to that as well, so you don't have to worry about that. I'm just sort of showing you here what it was back then, and this committee, nothing. I mean, they just sort of tell you guys the different modifications. Back then you needed a .h to work with this function. Now you do not. Back then you didn't have to using namespace std. Std is nothing but standard, but now you do. So all this has significance, which I will be telling to you shortly. All right, so let's discuss some of the basic features of the C++ programming language. It's a simple programming language in the sense that programs can be broken down into logical units and parts. So because C++ is an object-oriented programming language, as you can see here, it has the concepts of like I mentioned before, classes, objects, inheritance, polymorphism, data abstraction. Don't get overwhelmed by these terms. You just you will get to this. This is just a basic session, so I don't get to that. So yeah, it has a lot of features. For example, even the C++ programs, they excel in the execution speed because it's a compiled language. So if most of you know, Python was an interpreter language. It was an interpreted language, but C++ is a compiler-based language, which means that, for example, you have a program written and say it consists of 10 lines of codes, right? So when you debug the program or when you try to run the program, all the errors, say that there's an error in line 5 and there's an error in line 7. So all the errors, the compiler will show it to you in one go. That in this line, this is the error. In the next line, this is the error, right? So it's a compiler-based language, and that's more or less about it. So and of course, it's case sensitive, which also means, for example, you take an integer data type. So when you write int, when you type int in small letters, it carries a specific meaning, right? It's a keyword. It carries a specific meaning, or you can say an instruction to the compiler. But same thing when you type int in capital or with some other variations, it's a normal variable and it does not carry any specific meaning to the compiler. Then you can use it as a variable. All right, having said that, let's get on to the data types in C++. So what are data types? Data types are just the means to identify the type of data and the associated operations for handling it. Okay, and C++, it gives us two types of data types. One, as you can see in your screens, it's fundamental data types, and the other is derived data types. So let's go one by one. So in the fundamental data types, the first one you have is the integer data type. Now, what is an integer data type? It's nothing but, integers are nothing but whole numbers, right? For example, say 5, 7, minus 19, 0. All these are whole numbers. They do not have any fractional part to it. And thus, to store any values like these, like I said, 5, 19, minus 10, 0, all these they don't have fractional part to it, they're whole numbers. And so we can use if we want to declare a variable which is of the type int, you can put it you can use the integer data type. Next, moving on to the character data type. Char is the character data type. So you can say that any alphanumeric that you want to store, for example, say small a, capital B, capital Z, all of these, or even your asterisks and all of these alphanumerics, basically, in general, if I say, when you store these values in a single quote, that's when you can store the variable in a character data type. That's when the compiler knows that it's a character data type. Moving on, you have the float data type. So float, as the name suggests, a number having a fractional part is a floating point number. Right? For example, say 3.14. So whenever numbers have a fractional part to it, like the numbers after the decimal point, they come under the float data type. Going next to the double data type. So some of you can also ask that double does the same function that float does. It's used for handling floating point numbers. So some of you might be having a doubt that if we have float, why do you need double? They're doing the same job, right? But let me tell you here, double is treated as a distinct data type because there are two reasons. One, because it occupies twice as much memory as the type float. All right, it occupies twice the memory as that of the float data type. And also, it stands for the. You can say that it stores floating point numbers with a much larger precision, with a much larger range and precision, and that's why double is treated as a different data type. Then coming on to void, going to void. Say for example, sometimes you don't want to return a value, or your functions don't necessarily return a value, right? You just have print statements and all of that, and you don't really want to return a value. That's when you use the void type. It specifies an empty set of values. It's used as a return type for functions that do not return a value. So, and yeah, you do. Yes.
Madam, what about the type long, ma'am?
All right. So long. Okay. So there's a category called data type modifiers, and in that you have other than these fundamental data types are the 5 data types. These are the basic. All right. When you want additional features to this, for example, signed, unsigned, as you mentioned, long, short, all of these are called data type modifiers. They have their own set of a long integer is at least 4 bytes and at least as big as int. So they have their own set of instructions that they carry to the compiler, but these 5 data types are your basic, like these are your fundamental data types. Okay. All right, let's move on to the derived data types. This can be one second. Yeah, so this can be a little overwhelming for just the basics. Arrays, functions, pointers, reference constants. You can, of course, get to this when you just begin coding and you get used to the concepts and all of that. So we won't go there. I'll teach you guys functions, a little bit of functions today. But yeah, I don't want it to be overwhelming since it's just the basics. So, all right. So how to write a program. This is the basic program in any programming language, right? Hello world program. So here As you can see in your C++ programming language, these first two lines are the basic ones that you will write in all of your C++ programming languages, right? So your hash include, like I said, I'll tell you guys, your hash include is nothing but it's a preprocessor directive, which means that it's an instruction for the compiler that needs to be carried out in the programming stage. Okay, and what's a pre-processing stage? A pre-processing stage is nothing but a stage before the actual compilation of the program code. So that's what your hash include is all about. And your IO stream is nothing but your header file. Here we are using IO stream because we want to import certain functions. For example, cout. Cout is what? It's an object of the output stream that is used to show the output onto your screen. So this cout is a function that is being imported using this header file, that is IOStream. IO is nothing but it stands for input output, right? And then let's get on to using namespace std. So namespace std, say for example, there are two students in your classroom who have the same name. For example, say Vishal. There are two students whose name are Vishal, right? And now if you want to differentiate between them, you will have to use another unique parameter so that people know who exactly you're referring to, right? And same goes in with namespaces in C++. You might have a variable named, for example, int a. For example, a is your variable name, okay, in your C++ programming language. And so suppose you're using int a is equal to 10 in your programming language. And these header files that you import, right, you don't know what instructions and codes have been predefined for these. So say IOStream also has a variable named a, int a, okay. In that case, the compile, if you do not give namespace, using namespace std, your compiler, there's no chance your compiler can differentiate which int a you are referring to, which variable name you are referring to, and which should be accessed or printed or whatever you're doing with that after that. So a namespace is designed to overcome this difficulty, and it's used as an additional information, like I said, that unique information to differentiate between, say, similar functions or variable names, like I told you guys. Okay, and then what does using do? So the keyword using technically means use this whenever you can. Okay, it refers in this case the std namespace. So whenever the computer comes across cout, right here. Cout is a printing statement. Like for example, in your C programming, you have printf, and in Java, you have something else. In C++, we use cout, this function, to print whatever you want to onto your output screen. So whenever this using comes across cout or cin is used to take the user input. I'll tell that to you guys when I go on to the programming bit of it. So whenever if you don't give using namespace std here, every time that you cout, you will have to write std semicolon, that's your scope resolution operator, and cout. So this is something we're doing globally so that you don't have to repeat those set of instructions again and again, or each time that you use your cout or cin. Okay, and of course we're returning a value here because I'll come to this. We're returning a value here because your function is of the type int. I'll come to that, don't worry. Header files, hash include using namespace std. Yeah, I just explained this to you guys. So the main function and print statement. Okay, we'll go to the programming bit of it. Okay. Are you all able to see my screen?
Yeah.
Okay. Great. Type a basic program. Say hash include
Your programming is visible.
I'm sorry.
Your programming looks visible.
Your voice is breaking. Can you please repeat?
Your programming screen is not visible.
Oh, it's not. Okay, just a second.
It's just showing pros and cons.
Okay, just a second. One second, you guys. Okay, is it visible now?
Yes, ma'am. Yes,
Yeah,
Saniya, it's visible.
Yeah, it's visible.
All right, thank you.
Yes, ma'am.
Let's save this so that you guys know what's happening. Testing. So each time you save a program, I'm sure you guys know that by now we need to give an extension. And so for C++ programming, you give the file name dot your CPP, that's your extension. And so the compiler knows that it's a C++ programming language. All right, so like I said, the first statement is your hash include IOStream. And then you write using namespace. I hope the font is okay for you guys. Or do you want me to enlarge it? Is this font okay for you guys?
It's good.
Yeah, it's fine. Yeah, it's visible.
Yes, ma'am.
Okay. All right. So so you've written the first two lines. Sorry. Okay. So I'll come to this, the main function. So every C++ programming language has one function, and that's your main function. Your main function is, you can also call it your driver function, because your compiler starts its execution and ends or terminates the execution of the program from the main function, right? And in C++, we generally, of course, your data type of the function, it can be anything out of those 5 fundamental data types that I told you: float, void, double, int. But in C++, we generally write int because because the reason as why we return, no, one second, I'll tell you guys. Right. Okay, so the reason why we write int is that the proper way of writing the main function in C++ is to use an int return type for both. For example, even for C and for C programming languages, the standards and specifications mention that the main function should return some value, and hence we generally use int as the return type of the function. So here we've taken the data type int, and we have a variable num. Okay, so this is called your variable declaration. When you give the data type and followed by your variable name, that is called your variable declaration. And when you give another data type and followed by a variable name, and suppose say you assign a value to it, this is called your variable initialization. Okay, so we'll just do a small program to let you guys know what cout and cin really stands for. Let's say we'll do a small if-else program to just say we'll do an even-odd function to check if a number is even or odd. that's being entered by the user. Enter the numbers. Okay, so first let me tell you what cout is. So like I mentioned earlier, cout is an object of the IOStream header file that is used to show some output onto your screen. And after cout, each time you want to print the value, you have to use this operator. It's called the extraction operator. Let me just write it here for you guys. So this is called your extraction operator. Okay. So each time you want to print a value or a variable, whatever, you have with the cout operator, with the cout function, you always have to use the extraction operator. And then when you take the user input, you use this function called cin, right? So cin is just, you can say, the opposite of cout. It's an input statement and it's an input function, and it's used to take the user input. You use this variable. This variable is called the insertion operator. Okay, so each time you want to take a user input, you take the insertion operator. You use the insertion operator along with the cin. Okay, let's get to a basic one. Say if now we're doing, like I said, we're doing this program to check whether the given number entered by the user is even or odd. Right. For that, I hope you all know this operator. It's called the modulus operator, and on division. So whatever the number user enters, that will we're dividing it by 2 to check if it's odd or even. This is the condition is equal to 0. And of course, if it's 0, so this operator, the modulus operator, gives you the remainder, right? After the division, it gives you the remainder. And if the number is 0 entered by the user, if it's an even number, it'll return the modulus, you'll get a remainder 0. If it's 0, your control will enter into the if function, and you can print it's an even number, right? And L. So end L, I'll come to end L. In which you can go to the else part of it. Else, if it's not returning a 0, you know that it's not, or you can write it's an odd number. What does end L do? So end L is another function, and this function also we are importing it from the IOStream header file. So this, it doesn't do much, it just shifts your control. So suppose you have, say, another line here, cout, say you have high, okay? So say cout, you have high. So after, suppose, say you have entered the number 6, and after this calculation is done, the condition is satisfied. Accordingly, it will enter the loop and it's going to print whatever is here. It's an even number. And then whatever the next line is, this will be printed in the next line. It won't be printed immediately. Let me just run this and show it to you guys. So suppose your number is 6. You see here what endl does is basically a new line feed. So you either use /n, the shortcut, or you can use endl.
Your program output is not visible.
Oh, okay. 1 second. Let me go back. Okay, 1 second. Right, can you see it now?
Yes.
Okay, so here you see that once I gave my value, the user gave the input, I've printed it's an even number because the condition has been satisfied, right? It's entered the loop and it's printed the statement. And once it's encountered endl, whatever is there after that, it's printing it in the next line. Okay, you guys can see the code blocks, right? Or not?
No, we're not able to see the code blocks.
Now?
Yes.
Yes. Yes, it is visible.
Okay. Right. So, right. So I hope you've understood this bit of it. It's a very simple program. And return 0. Let's come to return 0. So, because like I said, when you don't want your function to return any value, you use the data type as void. But here, since our function is of the data type int, we have to return a value, and so we return 0. Okay. In case you don't give this statement, suppose you don't give this statement, and you run your program, your compiler will not throw any error because by default, when you declare your function of the type int, right, your compiler will take the return value to be 0 if nothing is specified. Okay. Having said that, let's move on to the next program. Okay. Let's move on to a for loop. All right. So, like we did a simple program on if then else, like your basic conditional statements. Let's move on to some of the iteration statements. Okay, so iteration statements are nothing but they're just like a set of instructions that you want it to be performed repeatedly until a certain condition is fulfilled, right? And in C++, we have 3 kinds of iteration statements. We'll see all of them. The for loop, while loop, and there's do while loop. So first, we'll see the for loop. Again, here we have our hash include. We've imported the header file. We have our using namespace std, and we have our driver function here. So let's come to the for loop. So, so every for loop here, there are 4 things that you need. First, you need to initialize your looping variable. Now, what's a looping variable? It's the variable where you initialize and it takes care of the number of times you want your loop to run. So that is called your looping variable, and here we have I as our looping variable. You can, if you don't want to initialize it here, you can do it outside as well. That doesn't matter. Say I is equal to 0, semicolon. Semicolon is used in C++ to terminate your statements so that the compiler knows that that's the end of the statement, right? So you can declare, yes?
Will you please increase the font size?
Oh yes, sorry. Is this better now?
Yeah.
Great. Okay, I'm sorry about that. All right, so here, this is again your variable declaration, like I told you guys. So you can declare your variable outside the for loop, that is fine, but you will have to initialize it here, right? After that comes your semicolon, that's the syntax. And then this is nothing but your test expression, basically your condition, how many times you want the set of instructions within the for loop to run or to be executed. So in this case, in this program, in this particular program, we're doing nothing but we're just printing numbers from 0 to 10, less than or equal to 10, right? So, and after that, of course, you have semicolon and You have your increment, decrement. This is called your update expression. Let me write down that for you guys. So when you do this, or say you do I minus minus, right? These are called your update expression. These are your update expressions. Okay. And then, so let's dry run the program. It's very important that before you execute or write down your programs, you dry run it. Dry running is nothing but, say for example, in this program, first, the value for your I is 0, right? And then because 0 is less than 10, your compiler, your control comes within the for loop and it executes all the statements. There can be n number of statements here within the parentheses and they will be executed. And then it comes on to your, so once first set of iteration is done, your control comes back here and your updation is happening here. So yeah, I++ is your updates expression, and then your I becomes 1. Right, so when I is 1, you can see again it goes on to check if the condition is true or false. Only when it's true, it will go for the second set of iteration. Second set of iteration is nothing, basically whatever is there within the parentheses, it will execute that. Okay, and then so on and so forth. So your I goes on to 3, 4, 5, 6, 7 until the condition is satisfied. In this case, until 10. So imagine your I goes on to, it's getting updated, and finally at the end, your I is, say, 11. And then it comes to the conditional statement. Now, because 11 is not less than or equal to 10, your iteration won't take place. Your control does not enter the for loop, and it will come out and execute the rest of the statements if there are any. Okay, so let me run this program and share this. You guys see this here, my output screen? So there's 0, 1, 2, 3, 4, 5 all the way up to 10, and 11 is not executed because the condition, whatever we have specified, is not the particular set of statements that are there under parentheses is not executed. Right, let's go back to code blocks. Okay, so that's the for loop for you. Let's come to the next one. That's your while loop. So a while loop is the second, it's a second iteration statement, you can say, or looping statements. A while loop is also called, let me write it here for you guys. A while loop is also called an entry control.
Please increase the font size.
Right. Is this fine?
Yeah, it's fine.
Okay. So your while loops are called entry controlled statements, and that is because where the loop body may maintain a single. So basically, okay, I'll come to that. So your while loop, the loop body may contain a single statement or a command statement, or it can even be an empty statement here, okay? The loop iterates while the expression here is true or false. So whenever your expression is true, your iterations take place, your control comes into the parentheses, and your set of codes are executed. And if the condition is not, say the condition is false, it's not satisfied, your control will not come, your iteration won't take place. And this is the syntax for while loop. Of course, you can initialize a variable outside, but the updation needs to happen here within the while loop. Okay. And that's basically it's the same program that we did in the for loop program that we did using the for loop. It's going to print your numbers from 1 to 10 here. You can always initialize whatever you want. You can start from 5, you can start from 7, and whenever your condition is fulfilled, your iterations will take place. Okay, that's your while loop. And let's move on to your do while loop. I'll increase the font size. All right, so unlike your for loop and while loop, your do while loops are called, or they are an exit controlled loop, right? So unlike your for loop and while loop, your do while loops are an exit controlled loop. Because the first thing that your do while loop has, it does not have the condition here. If you remember, in your for loop, immediately after you initialize your variable, you have the condition. Only then it will enter your loop, right? Only then it will execute your set of instructions, whatever is there within the parentheses. Similarly, even here in while loop, first it checks the condition only if it's true. Only and only if it's true, your set of instructions are executed. But in do while loop, where for the first iteration, your condition does not have to be true. Even then, your control will get into your do while loop, right, and execute the statements that you have, because your condition comes only at the end of the while loop, right? And even this program is doing the same thing what the other programs did using your for loop and your while loop. It's going to print numbers from 1 to 10. Again, you could give, say, 2. It could run from 3. It could run from 5. Whatever, that doesn't matter. You could increase this. You can make it 100. If you want numbers, if you want to print the first, say, natural numbers, start from 1 and then you go up to wherever you want to print. You can also take this as the user input and use that variable here, right? And so this is how your a simple program looks in a do while loop. You always have to give semicolon after your while loop. This is very important. If you do not give this, your compiler will throw an error that something is missing. That this is a syntax error basically if you do not give your semicolon here, right? So that is about your do while loop. Having said that, let's move on to a little bit of advanced concept. Not really that advanced, but this is something you would want to know. Let's come to functions. All right. So right. So a function, let me tell you, I'll write it down for you here as well. So functions are nothing but it's a named unit of a programming language, or you can say a named unit of a program that you can use to invoke, or that you can say, let's say in the layman term, that you can call again and again, right? So a function is a named unit of a program that can be invoked from other parts of the program as well. So say you can also, you can have a doubt that when you take your loops, they're doing a set of instructions for you so that you don't have to write them again and again, right? They're doing it for you as many numerous times as you wish. And function also does the same thing, but what's so different about functions? So functions you can call in any part of your program. Say, suppose here you have your int main. Let's get to this one. So your compiler first comes to the int main because this is your driver program. Here, say, suppose you have int a is equal to 10. It's going to read that. This is your initialized a variable. You can have so many other things, like you can say you have hello here, whatever it is, right? It'll print, it'll do the execution of the statements here for you. And this particular thing is called as your function. This is your function call, right? So as and when the compiler reads this, like you can see, your function name is greet, and you will use the same function name that you have defined here to call the function, followed by these parentheses and semicolon, right? So this is called a function. You can call your function in any part of the program. You cannot do that for a while loop. You write a while loop and your say your compiler executes it and that's it. It's repeating itself, yes, but you can't call that again and again, right? A function, suppose, say you write your while loop now within this function, and you keep calling the function as and when, wherever you want, whenever you want to execute, say the first 100 natural numbers itself, you want to print again and again. So wherever you call your function, the control goes to the function, it prints the statement, and then it comes back to your main statement. Say, for example, you have another function here of the type float. Say this is your function name, and you have a set of statements here. Here as well, you can call whichever function you want, and the job will be done. Your control goes to the function which is being called, right? It goes to the function which is being called. These set of statements, it can have so many statements that you want to execute, right? It can be else statement, you can have loops, you can be calculating here and doing all sorts of things here for execution. And then after it is done, your compiler, the control comes back here wherever you have called the function. Okay, so this is a basic function program. Do you guys have any doubts till now?
I have one doubt.
Yes.
Can you explain also in the use of namespace?
Sorry, can you come again?
Can you explain the use of namespace?
All right. Yeah. Okay. I'll explain this once again. So, say for example, here. Okay, here. Right. Say here we have declared a variable int a. Okay, we have initialized it. Fine. Now we're calling a header file. You do not know what codes or have been written by what codes have been predefined. This header file has so many functions and library. Say set of inbuilt functions like math.power, square root, and all of that. Right? You don't know what sort of variables is being used in this header file. Say IOStream only. For example, say you have int a even declared in your IOStream. We do not know this because we're the end user, we're the programmers, but the compiler does know that you have declared or you have initialized or you have used a variable called int a, and say there's a int a even in your IOStream, right? So that time there's no chance that say suppose now you want to print a. Sorry, C out. You're printing A. Okay, you're printing the value of A on your output screen. So now your compiler does not know which A you're referring to, right? It doesn't know if you're referring to this A, this variable that you have declared or initialized or whatever you're doing with it, or it does not know if you're referring to the same variable name that is in your header file. So that time, this namespace comes into play. So a namespace, it's designed to overcome this difficulty, like I just said. I'll just write it down. So it's use multi-line comment. So namespace is used to it's used to it's used by the compiler to differentiate the functions say variables, etc., which have the same name. This is what basically your namespace does. And
we have defined only one time.
Sorry, come again.
We have used A only one time.
Yeah. Okay. So I'll repeat it again. In this program, we are writing this program, right? Here we have used A one time. I'm saying this header file that you're importing. Why are you importing this header file? You're importing it because you want C out and C in, all of these functions. You want to use these inbuilt functions, right? That's why you're importing this header file. You're using this header file. Now in this header file, you do not know what variable name is being used or what function name is being used. Are you understanding? For example, let me tell you, the developer, whoever made this header file, would have used he also would have used int A, right? Or float A, whatever. So that time your compiler doesn't know. If you don't give using namespace std, if you do not give using namespace std, your compiler does not know whether it should refer to the int A that I have given as a programmer, or it should refer to the int A that is being already predefined in this header file. I hope you got the difference now.
Yes.
Right? Okay.
Yes.
Okay, great. So that's about namespaces. And okay, we'll come to, okay, this one. We'll just close our multi-line comment. So right, for single line comments, you use the forward slash twice, and for multi-line comments, you use a forward slash and an asterisk. This is called, the star is called your asterisk, and then you close it in the reverse order. You use your asterisk and then you use your forward slash. Okay, let's come on to, okay, I'll tell you guys something about, okay, for example, now your compiler reads your header file, it's reading using namespace std, and then control comes here. The control comes to, your compiler reads this, of course, it gets to know that yes, there is a function that it might have to execute. Okay, it reads that, it knows that there's a function, it's of the data type void. It reads this and it comes to the int function. The execution always starts from your driver program. That's your main function. Here it reads, okay, this int A, you're printing A, whatever, you're printing hello, whatever are your set of instructions that you want it to be executed, and then you have your function call here. And from here, when you have your function call, only then will the compiler come here to execute. Okay, I'll repeat this again. So once you've read, your program starts from here, you have your header file, you have your namespace std, your compiler reads this. It has understood key, okay, there's a function, I may or may not have to execute it, that is later, that the main program will tell me, or the function call. Then it comes here, the execution starts from here, whatever your set of instructions is, it'll be executed, and then when you have your function call, your compiler gets the control here and whatever statements you have here will be executed. Now, say for example, you're doing a complex program, and now this function. So you forgot that you had to add a function, but you've remembered it after defining your main function, and you want to add it here. It's fine. It's doable. But here, what happens now? Say you call your function here. So like I said, you use your function name, the same name as your function name, parentheses, and you give a semicolon. This is also your function call. Right? I've used func because this is the same function name here. This is the name. It's of the type float. It will have to return a value that we will see later. Don't bother about this now. But it has to return a value. Okay, because it's of the type float. Now, so once when your compiler knows that this function is there. No, wait. So yeah, now because your compiler, this particular function, void greet, you have declared it. This is, let me write it here. This is called your function declaration. This is called your function declaration. What is function declaration? Now, let me write a line here. Float, and then you have this and this. Okay, so this function your compiler knows that it's been defined here. Now, what do I mean by defined? There's something called as function declaration, and there's something called as just function definition. I'll come to that. Function declaration. Okay. So here, when you define your function definition is nothing but when you have your parentheses and you've given a set of instructions that you want your compiler to execute, right? When you come here for this particular function, now, like I said, the flow of control, your compiler reads this statement, #include iostream using namespace, and it comes here. Now, because this func, this function is declared after your int main, after your driver program. Initially, until it came here, your compiler does not know at all that there is a function named func that it may or may not have to execute, right? Your compiler has no idea. It has an idea about this function because you have already defined it before the main function. It has no clue about this function, right? So, and in such cases, if your compiler does not know there's a function after your main function, and you try to compile it, it will throw an error. It will say function not found or something like that. Okay, it will throw an error. So to avoid that error, to tell your compiler key there are functions or there is a function after my int main function, your driver function, but it's defined later. You just want to tell your compiler that there is a function. This statement is called your function declaration statement here. Okay. Why is it called function declaration? Because first of all, the syntax is you use the same data type as that of your function. You use your function name here, whatever you're defining later, and you use parentheses, and you use a semicolon here. You have to use a semicolon here. So here, once you type this line, your compiler knows that there is a function which it needs or which it will have to execute at a later on stage. Like you've just sorted in the mind key, yes, there is a function here. Say for example, you have another function, say int polynomial. You have parentheses, right? And you have your set of instructions here. Jo bhi hai. Calculate the value after calculating so and so, whatever, you'll give that, okay? But I'm just trying to explain what will happen here. So say there's another function after your main. Now if I try to execute this program, it will throw an error. Why? The compiler will say that it does not know. It will say that this polynomial function is not found at all. Okay, it will say that polynomial function is not found. So in order to tell your function that there is a function called polynomial which it will have to execute on a later stage. It's defined later. So when you function definition is nothing but when you have your function data type, the return type of your function name, your parentheses, and then your set of instructions or codes that you wanted to execute. And this is called your function definition. This, when you're just telling the compiler that there is a function definition that is being defined later after your main function, you just tell your compiler that this is the syntax. Your return type, it has to be the return type. You can't have a float polynomial here in your declaration. Okay, in your function declaration, you can't have a float polynomial here, but have it defined as int. That will again be an error. Okay, so this is the basic concept behind, this is what function declaration and definition is. So either you write your functions before your driver function in order to tell key this is it. Else, if you want to define your functions after your main program, which is also fine, you just need to add this extra statement that is your function declaration. All right, do you guys have any doubts until here? Any doubts, guys? If there's no doubts, can I please quickly see a thumbs up? I hope the space is fine. I'm going as slow as I can. I don't want this to be a little overwhelming as well. It's just the basic, right? Are you guys fine with this? This much? Any doubts until here? No? No doubts?
Will you please once open while loop?
Okay. While I'm there. What's your doubt?
Where is while loop? I can't see. Oh yes. We haven't used return statement here. Why?
Yeah. Okay. Thank you for the question. So in C++, by default, when you have your int main as the return type of your function, of your any function, not just main function, it's obvious, I've told you guys, other than void, if you're using int, float, double, all these, you need to return a value here. But when you're using int for functions as the return type, even if you do not give a return statement, like for example, in this program, I haven't given a return statement, your compiler in C++, only for the data type int, not float or double, okay? Only for int, it will by default return a 0. Like, remember we used to manually write a return 0 statement? In this program, I haven't. Like you said, I haven't. Because for the data type int, when you're using int as your function's return type, and you're not returning a value, by default, the compiler will return a 0. Okay? The compiler is taking care of this bit only for the int data type. I hope that answers your question.
Yeah, got it.
All right, great. So having said that, you guys, these were some of the basic programs functions was something I thought it'll be fine for the initial stage, and that's why I.
Excuse me.
Yes. All right, let's go to function. Okay, so a function prototype, I'll write it down for you guys. Prototype. Right, so a function prototype is nothing but it's a declaration of the function of, oh my god, my spelling's a little messed up, bear with that. So it's a declaration of the function that tells the program about the kind of value that you will return, or that your function will return. It also tells about the parameters. Let's not get into parameters here, but it can be a little too much for the basics, considering that it's just a basic session getting started. It tells about the parameters, which are also called as arguments. Right, and the number and type of different arguments. Let me close this for you. Right, so a function prototype is nothing but it's a declaration. This, like, you can also say that a function declaration is also a function prototype in short. Okay, so when your compiler, when your function is defined after your main function and your compiler doesn't know about it, I've told you it'll throw an error, and so you have to declare your function beforehand, just this part of it. So function declaration is nothing but it's also called your function prototypes, just another term for it. And it tells you the return type of the function name, and if you have any parameters, which we won't be taking up in this session, but if you have any parameters, say int or float, whatever it is, you will have to mention it here. And the different types of parameters and the number of parameters, all that's on a little bit too much, but that's, in short, the function declaration is nothing but your function prototype. I hope that answers your question.
Thank you. Also, will you be sharing these programs?
Yeah, sure. I'll push it into my GitHub account. So if you guys wish, you can fork it from there, or I'll even be sending it to the club, the board members, and they'll be sharing it with you. So yeah, that'll be taken care of. Don't worry.
Thank you so much.
You're welcome. Okay, so having said that, guys, these were just the basic programs that I sort of wanted to tell you guys about. We went a little into functions because I thought, these are some of the easy steps. I hope you guys got the concept here in the logic. There's so much more to functions. There's call by value, call by reference, but I didn't really want to take it up in this session. Just wanted to keep it basic. I just want to give you an idea basically how it works. But of course, if you're still interested in being a pro, you want to be good, you want to learn the C++ programming, you can always go on to Udemy or other courses, and just like I said initially, if you want to be good at it, you will have to get your hands dirty, okay? You will have to code it. You can code it on, again, code blocks if you're comfortable with. I've been coding on code blocks since, say, now 3 to 4 years, and so I'm comfortable for C++ with code blocks. You can also do it in Visual Code Studio. There's so many other IDEs that support the C++ programming, that has the C++ compiler, and so you can do that. Having said that, we're almost towards the end of the session, and I kind of want to just end it by quickly, just go take you through the pros and cons of C++, because you guys can be wondering that I know C, I know Java, why should I learn C++, right? What is there in C++ that is not there in C or Java or any other programming languages, or what's unique, right? So like you can see on your screens, I'll just slideshow. Can you guys see my PPT?
No, ma'am.
Okay, I'll just go to that. Now?
Yeah.
Yes, ma'am.
Yeah, it's visible.
Yes, yes.
Okay, great. So yeah, I just thought I'll quickly take you guys through the pros and cons. So portability, so C++ programming languages, programs are portable or platform independent. You can say, yes, like I mentioned before, they are it's an object-oriented programming language, so it has so many additional features to it, which you will learn later on in the advanced concepts. It also has pointers, it has classes, objects, data abstraction, encapsulation, polymorphism, all of these, right? And like I showed you before, in say this slide, it has unions, it has structures, reference, enumeration, constants. So all of these just helps. It has friend functions, all of these. Once you learn what it is about, when you get into the programming like in detail, the advanced concepts, you will, I'm sure, have fun. It'll be fun to code from there on, and that's more or less about the pros and cons. Of course, the memory management is great in C++ because the speed is great because it's a compiler-based language and it has a large community support, right? It's compatible with C to some extent, right? And then these are some of the advantages that really weren't there in C, and it's there in C++. Of course, disadvantages. Pointers can be both an advantage and disadvantage, because it usually comes under the disadvantage part of it, because first, the concept is a little overwhelming. It can be a little confusing. Second, here using pointers, like I mentioned earlier, that pointers are used for manipulation in your memory directly. So the programmer can actually go and manipulate the kind of information where it's stored and how it should be stored, etc., using pointers. So that's there, and there's a security issue with to some extent. Although it's an object programming language, it offers a lot of security to the data being handled as compared to the other languages, right? But of course, certain things like friend functions, global variables, all these pointers, even for that matter, there's always a pros and cons to it. So that's more or less about it. And some of the applications, this was just for you guys to kind of have, get an idea again. So GUI, graphical user interface. Although it's a bit complicated to use graphics in C++, no doubt, but it proves to be quite useful when it comes to the animation and design of interfaces, and then job opportunities, of course. Like you can see on your screen, C++ has an enormous job market, expanding to industries like finance, probably even your Chrome for that matter, to some extent. It is the backbone. C++ is the backbone of your Chrome and say Internet Explorer, Mozilla, Firefox, and then you also have your OS, of course. And then your web browser. C++ is, you can say, an optimal choice for programming the web browsers because of its high speed, because it's a compiled language. It offers, along with the benefit of data security implemented through the concept of OOPS, that's object-oriented programming language. And with that, you guys, we're towards the end of the session. If you guys have any doubts, you can always get in touch with me in LinkedIn if you have any questions. The programs, like one of you asked, the programs and the PPT, I'll push the programs into my GitHub. You guys can fork it from there if you wish to. I'll also be sharing the PPT with the management, and they'll be sharing it with you guys. And so with that, if you guys have any doubts, I would like to address them to the best of my abilities. Otherwise, if there's no doubts, great. Does anyone have any doubts? Guys, anyone has any doubts? Or it's good to go?
Chat box, there are questions.
Okay, I'll just switch over. Oh, okay, you guys have already shared the LinkedIn and all of that. That's great. Okay. No doubts, attendance form, okay. All right. I guess there are no doubts now. If there are any, guys, you can always, you can unmute or ask it in the chat box, type it in the chat box.
Guys, if you have any questions, just post it in the WhatsApp group. Take care of that. And Adi, you can take care of it, right?
So honorable speaker, president of ICOS, teammates and participants, good afternoon. My name is Aditya Singh Rawat. Would like to thank ICOS for holding me this. So on behalf of the committee, I would like to thank our honorable speaker, Saniya Pandita, who graced us with her presence and guidance. I would like to express our sincere thanks to Saniya Pandita for giving excellent coverage on the topic C++. So thank you everyone for joining it. And guys, please follow us. Links are provided in the chat box. Thank you.
2 credit course students, please fill the attendance form. It's mandatory for you. It will go to VIT. So please make sure you fill the form. Everyone can leave the session.
Can you tell why is it mandatory?
For 2 credit students, innovation in engineering students, it's mandatory to fill the attendance form. For second years, not first years.
Is it a club or chapter?
It's a club. Innovator's Quest.
Bro, and the event name?
Just mention introduction to C++.
Okay.